Assalamualaikum warahmatullahi wabarakatuh. We are from Group A, Section 1. We'll be presenting our open-ended laboratory titled Electroplating for Different Electrolyte. Now, I will introduce our group members. First, me myself, ADIB HAKIMI bin Abdul RAHIM. Second, AFIQ NAUFAL bin Muhammad RASHID. Third, AHMAD NADZIM bin JAAFAR. And fourth, AIMAN RAFIQ bin RASHIDEE.
Assalamualaikum warahmatullahi wabarakatuh. My name is AIMAN RAFIQ bin RASHIDEE. My matrix number is CD20070. I am from Group A, Section 1, and I will explain about abstract, observation, and conclusion. For the abstract, this report shows the result of an experiment that used stainless steel as the anode, mastic as the cathode, and electrolyte solution use carbonate water, salt water, liquid detergent to investigate the experiment. The findings help in the optimization of the electroplating operations, assisting business in achieving desired plating quality.
Now, I will presenting our introduction for this experiment. There is constant demand for components to have the smallest possible dimensions, whether it is to save weight or the cost of materials. It's almost as if the failure of the component or assembly in issue is a process that is intended to occur in the absence of any compensatory measures. A commercially significant procedure, electroplating is frequently used to lessen corrosion or enhance the look of products. A thin layer of a desirable metal is applied to another item during electroplating. The object to be electroplated is connected to the negative terminal of a power source during the process, giving it a negative charge. As a result, the item will draw positive metallic cations from the electrolytic solutions or bath it has been immersed in. The main objective of this experiment was to look into the effects of these changes on the thickness, weight, and quality of the plated metal layer. By methodically changing the electrolyte and plating time, the result is identifying the perfect conditions for achieving the required plating results.
Assalamualaikum, my name is AHMAD NADZIM, and today I will explain the methodology for the experiment. So, material and apparatus. For this experiment, we use retort stand, sandpaper, 100mm beaker, stopwatch, electronic balance, set of alligator clips, ammeter, direct current, 12 volt, mild steel, stainless steel, and 3 electrolyte solution, which is carbonated water, salt water, and liquid detergent. For the procedure, first we grind the mild steel plate by using different grade of sandpaper. Next, set up the experiment apparatus for electroplating process as shown in figure 1A. And then we fill the 100mm beaker with carbonated water until reach the desired amount. And then we weigh and record the initial weight for mild steel by using electronic balance. Clip the mild steel at negative terminal, cathode, and clip the stainless steel at the positive terminal, anode. Switch on the power supply and set the stopwatch and wait for 10 minutes. After that, weight and record the mild steel final weight by using electronic balance. And we repeat steps 1 to 7 with the same electrolyte solution, but run the electroplating process and set the stopwatch for 30 minutes. And for the last step, change to another electrolyte solution and repeat step 1 to 8.
Assalamualaikum, my name is AFIQ NAUFAL bin Muhammad RASHID. So I will present for result and calculation part. For result, we have two tables. Table 1 for initial and final mass gram of sample after 10 and 30 minutes, where there are 3 samples which with different electrolyte, which is for the sample 1 is 100 plus carbonate ring, which for 10 minutes initial mass is 5.585 gram, final mass 5.594 gram, for 30 minutes 9.235 gram, and 9.242 gram for final mass. Second sample is electrolyte is detergent, where initial mass for 10 minutes is 5.5 gram and 5.512 gram for the final mass, and 30 minutes 9.175 gram and 9.185 gram for the final mass. And the last one for the electrolyte is salt water, where 10 minutes initial mass is the 5.406 gram and 5.422 gram for final mass, and 30 minutes 9.167 gram and 9.175 gram for final mass. For table 2 is where the mass is timed with the 9.81 to get in Newton, where for the sample 1, which is 100 plus, initial weight is 54.79 Newton. for the 10 minutes and final weight is 54.88 Newton. For 30 minutes, initial weight is 90.60 Newton and the final weight is 90.66 Newton. Second, for detergent, initial weight for 10 minutes 53.96 Newton and 54.07 Newton for the final weight, and 30 minutes 90 Newton and 90.10 Newton for the final weight. For salt water, for initial weight is 53.03 Newton and the final weight 53.19 Newton for the 10 minutes, and for 30 minutes 89.93 Newton for initial weight and final weight is 90.01 Newton. For the calculation part, we use formula difference in mass equals to mass final minus mass initial, where for my steel with 100 plus carbonate ring electrolyte, different mass at 10 minutes 5.594 minus 5.585, we get 0.009 gram, and different mass at 30 minutes we get 0.007 gram. For my steel with detergent electrolyte, different mass at 10 minutes 5.512 gram minus 5.500 gram equals to 0.012 gram, and different mass at 30 minutes equals to 9.185 gram minus 9.175 gram equal to 0.010 gram. And the last one for my steel with saltwater electrolyte, different mass at 10 minutes equals to 5.422 gram minus 5.406 gram equal to 0.016 gram. Different mass at 30 minutes 9.175 gram minus 9.167 gram equal to 0.08 gram. Below shows the table 3 mass of metal deposited in 10 minutes and 30 minutes for each sample. So from that we know that each sample where the electrolyte is different for each sample, it shows that the sample had been deposited from anode to the cathode, which means that there are mass that increase for the cathode part, where after we minus the final mass and initial mass. That's all from me.
For observation, the table below show the mass of metal deposited for 10 minutes and 30 minutes with different electrolytes. There's a difference in metal mass for 100 plus of 0.002 G as well as detergent. Significant change in metal mass of after 30 minutes can be seen from saltwater, which is 0.004 G. This difference occurs due to the different pH value of each electrolyte. 100 plus is carbonate water, often contains dissolvent carbon dioxide gas, which can combine with water to form carbonic acid. As a result, carbonate water tends to be slightly acid with a pH ranking from around 3 to 4. My steel is susceptible to corrosion when exposed to an acid environment. Carbonic acid can actually as a weak acid, and it can initiate a corrosion process on the surface of the steel.
Discussion. We conducted an experiment to compare electrolyte solution. For electroplating metal onto a mild steel surface, we clean the mild steel cathode and record its initial weight. Using beaker, a power supply and alligator clips, we immersed the stainless steel and mild steel in the electrolyte solution. We plated the cathode for 10 minutes and 30 minutes. Weighed it after each duration. We compare the weight gain for each solution to evaluate their effectiveness in applying a metal layer. We also compare the weight gain between the 10 minutes and 30 minutes duration to understand the relationship between plating time and quality of the metal layer. The initial weight of the cathode was important for calculation and evaluation. The experiment's result helped determine the best electrolyte solution and plating time. Considering factors like cost, accessibility, and desired surface qualities, further research can explore additional electrolyte solution and their impacts on electroplating.
Now I will presenting our questions part for this study. First question: what material should the plating bath be consisted of and why? So a solution containing the metal ions to be plated should be the base of the plating bath. The exact metal you want to put on the electroplate determines the type of plating bath material you use. Here are a few common examples of plating bath for particular metals. Like for copper electroplating, use copper sulfide as the source of copper ions in the plating bath, which is a solution. Second, what ions are present in the electrolyte? So the ions in the electrolyte encoded with metallic material studies depend on the metal being plated. Every metal has a singular plating bath and joint solution that holds alloy-bound metal ions. Here are any conventional instances like nickel electroplating. Nickel ions are present in the electrolyte ordinarily as nickel sulfide or nickel chloride. Third, give all relevant half reaction occurring at the cathode and anode for mild steel sample. So nickel is deposited on the steel surface as a result of the reduction at the cathode, whereas the oxidation at the anode produce oxygen gas and hydrogen ions. Through the regulated transfer of metal ions from the electrolyte to the mild steel sample made possible by these reactions, the steel surface becomes nickel plated. So the fourth question, through your observation, explain changes that occurred to the electrolyte solution during the electroplating process. So we use one of the sample is isotonic drinks. Isotonic drinks are one type of electrolyte that has been employed. If the electrolyte in an electroplating experiment was an isotonic drink solution, there is mainly water apart from electrolyte and mineral. The following modification would be visualized, like first, metal ion concentration, second, color changes, third, pH changes, and fourth, temperature changes, and fifth, metal build up. So the last question, is there final weight differences observed when compared to different type of samples and why? So the answer is yes. When comparing several types of sample in an electroplating experiment, ultimate weight variation can indeed be seen. The electroplating procedure, which deposits the plated metal onto the sample surface, is mostly accountable for the weight disparity.
This is the conclusion. In this experiment, we discovered that increasing the pH value of the electrolyte increased the amount of deposited metal, which is exactly the opposite of what we expected. We noticed that the potential difference had likewise decreased, and result that is could be due to the electrolyte's resistance. When the pH value increased, the resistance increased and the potential difference flat up. And the cell with the bigger potential difference creates more metal with the same amount of current. It is possible that the potential difference is more effective than the number of ions in the electrolyte. So potential difference should be a control variable when testing the effect of the pH of the electrolyte. That's all from me. Assalamualaikum.